See, dear students, let's do one question first. See, the given equation is TiO 2 plus 2H plus electron gives this. E naught is given this, and Ti 3 plus 3 electron gives Ti, and it is asked find E naught for this, right? So how to solve this equation? So first you have to examine that can we get this equation, this transformation from the given equation. So if you see here, if you add these two equations, so you will get this transformation. Or one more way you can do this, you can balance this to this by if you don't write to add this, if you don't want to add this, you can balance this by ion electron method. You will get the same answer, right? You will get the same answer. So TiO2 plus 2 gives if you add this two, and I am balancing this basically. So TiO2 plus gives Ti. So one more time you will learn how to balance this equation by ion electron method. See, first you have to see other than hydrogen and oxygen. So other than hydrogen oxygen element is titanium. So titanium here, 1 mole, it is balanced. Now balance the oxygen by addition of water. So one oxygen is there, so you have to add one water in this side. Now balance the hydrogen by H plus, addition of H plus. So here 2 hydrogen, so here you can add 2H plus, right? Now balance the charge by addition of electron. So see, right hand side there is no charge, and in the left hand side 2 positive, and this is 1 positive into 2, 2 positive, 2 to 4 positive. So total 4 electrons you can add. And now if you add these two equations, you will get this equation. So there are two ways to get this equation. Either you balance by ion electron method. Sometime what will happen, the same question may be given to you like this. See, suppose that the question is given like this: E naught for TiO2 plus 2 Ti3 plus. Sometime examiner may give you this type of question is equal to 0.1 volt, and E naught of Ti3 plus oblique Ti, this is equal to minus 1.21 volt, right? So, and find E naught for TiO2 plus 2 plus oblique Ti. So sometime what will happen, examiner may not give you the complete half equation, half reaction. They only give this couple, that this is converted into this is converted into this, and find the E naught value for the conversion of this into this. So in this situation, you have to write the equation like this: TiO2 plus 2 Ti3 plus, and you have to balance. Without balancing, if you are doing anything, you will be in the trouble. Here see, the equation is given, so you can directly add to get the equation for this, but sometime examiner may give you this type of data, and they ask, okay, find this. So there is no way to directly find this E naught value for this couple without writing the equation for this and balancing that. Because moles of electron, to find the moles of electron is very important, and until or unless you have not balanced the equation, you will not get the correct number of moles of electrons, right? So this is equation 1, this is equation 1, this is equation 2, this is equation 2, and this is equation 3, right? So how to get E naught for this? We are getting this equation 3. Equation 3 is equal to equation 1 plus equation 2. Equation 2. So this equation is the result of the addition of these two equations. So is it possible that we can directly add this E naught value? Can we directly add this E naught value? The answer is no. We cannot add this directly, this E naught value. So how to add this E naught value? So concept is given to you that you have to convert this first into delta G naught and then add, right? So you can write here delta G naught 3 is equal to delta G naught 1 plus delta G naught 2, right? So you can write delta G naught 3 is equal to minus N F and E naught of, if you want, you can write TiO2 plus 2Ti. This is equal to minus NF, or we can say N1F E naught of TiO2 plus 2Ti3 plus minus N2F E naught Ti3 plus oblique Ti, right? So you can write what is the value of N moles of electrons for the equation 3. See, this is equation 3, moles of electron is 4. So you have to write here 4 into F into E naught TiO2 plus oblique Ti. This is equal to N1. Equation 1, moles of electron are 1. So minus 1 into F into E naught is given 0.1, 0.1, right? Plus minus N2. N2 moles of electron in equation 2, these are 3. So you can write here 3 into F into E naught for this minus 1.21. So minus 1.21, right? So what we can write here, F cancel. So we can write minus 4 into E naught of TiO TiO2 plus oblique Ti is equal to minus 0.1, this minus minus plus 3 into 1.21, right? So you can write here E naught TiO2 plus oblique Ti is equal to 0.1 minus 3, 6, 3.63 whole divided by 4 volt, and this is equal to minus 0.8825. Okay, volt. This is the answer. So in this way you can calculate such type of question. Question may be given in this form or in this form, right? Okay, good. See, one more feature of this E naught, the same feature, as it is intensive, but suppose that one half reaction is given to you like Ag plus electron gives what? Ag, and E naught is given 0.8 volt. Suppose that it is given, and if sometimes it is asked, okay, find the E naught, find the E naught for 2 Ag plus 2 electron will gives 2 Ag, right? So what should be the answer? As per the thermodynamics, all of you are knowing in thermodynamics, if you multiply any equation by any factor, then the thermodynamic parameter that will also change in the same manner. But remember, this is an intensive property, so it is independent of multiplication, division of any equation by any factor, right? So the E naught is still 0.8 volt, right? You may put question why. So what is the answer, dear students? What should be the answer? Answer, because E naught is intensive. And if any property is intensive, then if you divide any equation or multiply any equation, that property will not change. Note down, this is very important point, right? Okay, now see the next point, second point. See, E naught should be always reported for a particular couple, right? E naught should be always reported for a given couple, right? What does it means? See, sometime you will see, many people are explaining this. Okay, E naught for silver, right? See, suppose that you have written like this, E naught for silver, right? So what does it means? Silver is going to it can be expressed like this: silver is going to silver plus, or silver plus is going to silver. You cannot decide. And both have different meaning, Both have different meaning, right? Both have different meaning. So this is a wrong interpretation, wrong explanation. E naught for silver. You should not try to express E naught like this. Don't say, even don't speak. You should always speak like this: E naught of Ag to Ag plus, or E naught Ag plus to Ag. See, E naught Ag to Ag plus, this is equal to minus 0.8 volt, and E naught Ag plus to Ag. So this is the representation of couple. So you have to always express the E naught value in the form of couple. Don't even speak in the wrong way. So every time be extra careful that how you are spelling this, how you are writing, that is also very important, right? So E naught should be always reported for a given couple. Suppose that you are speaking like this, you are telling like this: E naught for iron. And what is this? E naught for iron? Hmm? Iron 2 plus 2, iron 3 plus, iron 3 plus 2, iron 2 plus, or iron 3 plus 2 iron, or iron 2 plus 2 iron. What you are trying to say? So don't speak ambiguous terminology. Don't write ambiguous terminology, and it will always put you in the trouble. So every time what is happening there, you should clearly mention what is converting in what. Means you have to express E naught value categorically for a particular couple. Because see here, and the huge difference is there in the this representation. Don't say the value is same. Not this value is not same, because next point I am going to tell you about that. Okay, so every time whenever you speak, and in the live session I will ask you, everybody, I will ask to everybody that you have to tell me, speak this, couple, right? So every time you have to speak and write properly E naught value for a given couple. Now see the third property of E naught, that E naught values for a given couple, for a given couple is always treated with sign. With sign, quote it, very important point. With sign means E naught values are not considered, are not treated magnitude only, right? So suppose that E naught for A2 plus 2A is given 0.23 volt. E naught for B2 plus 2B is given minus 0.75 volt, and E naught C2 plus oblique C is given minus 1.23 volt, right? So first it is identify that what these values are given. These are reduction potential or oxidation potential. See, 2 plus is converting into neutral, 2 plus converting into neutral, 2 plus is converting into neutral. So definitely all these are the reduction potential, right? So it is a reduction potential. How I have decided this is reduction? By observing this couple. So by seeing this couple, you can easily assess, okay, this is reduction. So this is reduction, and this is also reduction. And if you want to compare, okay, compare that, see, uh, arrange these couples in the order of their increasing reduction potential, right? The question is arrange these couples in the order of, in the increasing order of, in the increasing order of reduction potential, right? So see, these values always you have to consider with sign. This is very important point. Always consider with sign. So this is minus 1.23, this is minus 0.75, this is 0.23. So the reduction potential for A2 plus is maximum, then B2 plus, and then C2 plus. See, the first part of the couple, the potential is for that only, because we always read the equation from left to right, not right to left. So this is the order of reduction potential. Suppose that in the same data it is asked, arrange these couples in the order of increasing order of oxidation potential. Arrange above couples in the order of, in the increasing order of oxidation potential. Oxidation potential. Oxidation potential. So how to do this? First, you have to write the oxidation couple. E naught A2 plus. Once you have changed the couple, sign will immediately change. So now this is minus 0.23 volt. Now E naught B2 plus. Now this becomes positive 0.75 volt, and E naught of C2 plus, now it becomes 1.23 volt. 1.23 volt, right? So in this way, this unchanging couple, the value will change. And already I have told you that the oxidation and reduction potential, standard oxidation reduction potential for any given couple is equal in magnitude but opposite in sign, right? Now this is minus 0.23, this is plus 0.75, this is 1.23. So the increasing order, so this is what I have asked, increasing order but written in the decreasing order. Increasing order, C plus, B2 plus, and A2 plus. plus, right? Now it is okay. And see here, in this case, increasing order, so lowest value is for A, then it is for B, then it is for C. So this is the increasing order of their reduction potential and here oxidation potential. This is oxidation potential and this is reduction potential. So this is the proper way how to convert and how to assess and how to read and how to interpret the E naught values. And many people are doing mistake here. They do not properly write, do not properly spell, do not properly interpret these values, and that's why they do the mistake here, right? So this is very, very important feature of E naught. Now next feature, I'm going to tell you the fourth feature of this E naught, that the couple for which the given potential is high, algebraically high, means with sign you have to observe. So couple for which the given potential is algebraically high, that type of reaction is favored on that couple. This is very important tagline. So the couple for which the given potential is high, with sign, right, with high, that type of reaction is favored for that couple. See, if oxidation potential is high, then oxidation reaction is favored. If reduction potential is high, then reduction is favored for that couple. Now see, I am taking this example only. So for which suppose that if we I am demonstrating you in this manner. Suppose that two electrons were kept at the center of this. I am assuming that it is present at this center, and A2 plus is here somehow, B2 plus is somehow here, and C2 plus is here. Now all these ions are approaching to this electron. Now see, for which species, for which couple, for which here see reduction potential is high for this couple, means high for A2 plus. We have already arranged this. So A2 plus have the greatest tendency to accept the electron among these three. See, so if this electron is kept in the center at equal distance from these three, and all are approaching this two electron, which one is the winner? Number one. So number one is what? A2 plus. This is number one. And number two, B2 plus. This is number two. And this is number three. Right. So which one is the winner? Winner is A2 plus. So what I have written here, that is I have represented here, the couple for which the given potential is high with sign, that type of reaction is favored for that couple. Means A2 plus preferentially reduced. A2 plus preferentially reduced over B2 plus and C2 plus. Therefore, or one more point I can add here. A2 plus preferentially reduced over this, or we can say A2 plus have more tendency to get reduced than not B, not C, B2 plus and C2 plus. Very careful what species you are comparing. Or you can write one more thing here. It all have the same meaning. Have more tendency to get reduced, and A2 plus have more tendency to accept the electron. Have more tendency to accept the electron than B2 plus and C2 plus. Right. So all three representations here all have same meaning. How I have decided this? On the basis of E naught. So if 2, 3, 4 species are given to you, or minimum 2 species are given to you, and it is asked that, okay, tell me that which species preferentially reduce. So what you have to do? If oxidation potential is given, then you have to convert that into the reduction potential, E naught, simply by changing the couple and changing the sign. And on the basis of that, you can decide. Very easy. Okay. So greater the reduction potential, greater the reduction potential, greater the tendency to accept the electron. And if any species have more tendency to accept the electron or tendency to get reduced, means that species is good oxidizing agent. So you can say that A2 plus is the best oxidizing agent among A2 plus, among B2 plus and C2 plus, yeah, or with B2 plus and C2 plus. So a reducing tendency means oxidizing nature. See, tendency is always assessed with respect to itself, and par is always compared with respect to the other. So you can say that A2 plus has the highest oxidizing power, is A2 plus has the highest or maximum oxidizing power, power in or compared to B2 plus and C2 plus. Because whatever comparison I am doing here in this question, that is among A2 plus, B2 plus and C2 plus only, right? Clear? Means A2 plus, or you can write here, or A2 plus is the best oxidizing agent, is the best oxidizing agent, best oxidizing agent among A2 plus, B2 plus and C2 plus, right? So now see, so we can put a note here for this note, and this is very important note. So we can write here that tendency to get reduce, tendency to get reduce, reduce or oxidizing nature, oxidizing nature oblique power oblique strength, means oxidizing nature or oxidizing power or oxidizing strength is directly proportional to E naught reduction with sign, right? So whenever it is asked that what is the tendency to get reduce or oxidizing nature or oxidizing power or oxidizing strength, so you can directly compare the E naught reduction values. Similarly, the tendency to get oxidized, tendency to get oxidized, or reducing nature, or reducing power or reducing strength is directly proportional to E naught oxidation with sign, right? So suppose that in the above question it is asked which one is the best oxidizing agent, best oxidizing agent in the above, and best reducing agent, best reducing agent. Best reducing agent. Now see, for best oxidizing agent, you have to see E naught reduction. So for which E naught reduction is maximum? For E2 plus, A2 plus is maximum. So the best oxidizing agent is A2 plus. And best reducing agent, reducing nature or reducing strength, it is directly proportional to E naught oxidation. So E naught oxidation is highest for C. So C is the best reducing agent. So in this way you can answer such type of question, right? And on the basis of this magnitude of reduction potential or oxidation potential, whatever you want, one series is prepared that is known as electrochemical series. So we can see here electrochemical series, electrochemical series. So in this series, we arrange the different couples in the order of reduction potential or oxidation potential whatsoever. And now I am going to give you a very different electrochemical series. You won't find this series in your books. This is very unique. So see, this is although little bit dirty, but don't see, this is very old book. I have taken this from that book, and one of my favorite book of physical chemistry. But see, this is not as it is useful for all of you. That's why, and you won't find this book actually here in your local market. Okay. See, this is few important points I would like to highlight here. See, first very important point, and many people do not knowing this. See, standard reduction potential E naught, this is E naught for half cell at 298.15 Kelvin. pH is equal to 0. See, this table is means all these values of E naught were determined at pH 0. You won't find this data in any normal books, right? Okay. Now see, in every book you will find this F2/F, right? You will not find a PT like this, what is given here. So now it becomes very clear that F2/F is not the electrode. Basically, over platinum, fluorine is adsorbed, right? Now see, cobalt 3 plus to cobalt 2 plus, this is the redox electrode, as already I have told you. So platinum, platinum, platinum. Now see here mercury and platinum wire is immersed in this. So this is the very accurate terminology. This is the electrode reaction, and this is E naught value. Now see, is this a reduction potential or this is oxidation potential? First you have to decide. See, electrons are added in the left hand side, so obviously this is reduction potential. Reduction, right? So what you are observing here, that from F2 to this last Li. So how to write this from F2 to F minus. Don't say fluorine, as I have warned you. Don't say fluorine. You always speak couple. So from F2 to F minus to Li to Li plus. Li to Li plus. Sorry. Li plus to Li, not Li to Li plus. Li plus to Li. Li plus to Li. See this. Li plus to Li, and from F2 to F minus. Right? E naught reduction. Now, apply your concept. E naught reduction decreases or increases? Tell. Observe this table. Decreases. E naught reduction decreases. Means what? Means what? Tendency to get reduced decreases. That is tendency to get reduced decreases. That is you can say that is F2 is the best oxidizing agent. Because for F2 the reduction potential, E naught reduction potential is highest. See, this is for this minus 3.05 and for this plus 2.87. So for which E naught reduction is maximum? For F2 to F minus. So F2 is the best oxidizing agent. Clear to everybody? Now you can say from, so what you can say from here to here, from here to here, E naught reduction decreases, right? E naught reduction decreases means oxidizing nature or oxidizing strength decreases, right? Now see, what about E naught oxidation? E naught oxidation. So if you observe E naught oxidation, so the couple will change. So F minus to F2 to Li to Li plus, the E naught oxidation increases. Means you will get E naught oxidation for this Li highest, because the sign will change. Here plus and here you will get what? Minus, because once you change the couple, sign will change. So that is tendency to get oxidized increases. tendency to get oxidize increases. That is, you can say that lithium the best reducing agent. Best reducing agent. So which one is the best reducing agent and which one is the best oxidizing agent, you can determine with the standard electrode potential. If E naught reduction is highest, then it is best oxidizing agent, and if E naught oxidation, then it is best reducing. So oxidation highest to reducing best, reduction highest, oxidizing best. So this is the way how to determine the best oxidizing agent and best reducing agent by comparing E naught values. So all of you should I mean keep this table with you, because whenever you are doing questions, sometime it is important to refer these values. Although in the question the values are given, no need to remember, but at least you should remember the order, that from uh, top to bottom it is increases or decreases. In other book you may find this is on the top and this is on the bottom, but don't confuse. You just observe what couple is given, it is reduction couple or oxidation couple. You may arrange your table in your way, no problem, right? So this is electrochemical series. This is very useful series to determine very different properties of elements. So first property we have taken here, that whether the given species is oxidizing agent or reducing agent, or we can arrange them in the order of oxidizing strength or reducing strength. Clear to everybody? Okay.